Hey, good afternoon, everyone. And for those of you on the West Coast, good morning. My name is Paul Deffenbaugh. I'm the editorial director at Metal Architecture Magazine. Today, we're doing a webinar, Strategies for Success with Aluminum Zinc-Coated Roofs, and it's presented by Steelscape. I hope you folks on the West Coast are staying cool. I understand it's nasty out there. We're joined by Michelle Vondran, who's going to be our presenter, who is also on the West Coast and trying to stay cool. And I'm going to turn things over to her in just a moment. If you want to ask questions during today's webinar, please submit your questions on the panel there. I'm going to monitor everything, and then I'll raise the questions with Michelle at the end of each section. There are 4 sections here, and of course, we'll do questions at the end of the webinar. For those of you who need AIA credits or those who aren't in AIA but want certificates, all of that will be handled automatically. Please allow 7 business days for everything to process. And tomorrow at about 2 o'clock Central Time, 2:15 Central Time, you're going to receive an email which will have links to the more information, also links to how to ask technical questions, a link to this presentation if you want to review the presentation, and download the presentation itself. So look for that email tomorrow. That will be able to handle a lot and make it easier for you to follow along today. But right now, let me turn things over to Michelle. Michelle Vondran is the technical manager for NS BlueScope Coated Products North America. She graduated from California Polytechnic State University, San Luis Obispo, and she got her Bachelor of Science degree in chemistry. She started her career as a research chemist with Mortar, which is now BASF coil coatings, and with a focus on polymers. And this position included lab development as well as lab to production scale up and manufacturing quality and process control. Eventually, Michelle's focus shifted to cool pigmentation, where she brought the first cool coil coatings to market. She has been active in the Cool Roof Rating Council and the Energy Star Roofing Program. She joined Steelscape as a quality engineer for the Rancho Cucamonga, California paint line. And while there, she has held the quality systems manager role and is now the technical manager. Michelle oversees quality systems and technical service for BlueScope Coated Products North America, which comprises Steelscape and ASC profiles. She's an active member of the National Coil Coaters Association, sitting on the technical committee, as well as, appropriate to today, the Zinc Aluminum Coaters Association. Michelle, take it away.
Thank you, Paul. Always a great introduction. I feel like I have a lot to live up to. Welcome, everyone. I do hope everyone's staying cool. Got all my fans on high here in Southern California. And fingers crossed that we don't have any rolling blackouts today like we've had every day so far this week. So thank you for joining us. So yeah, we're going to talk about aluminum zinc coated metal roofs today. And here's the information you all need to know, our provider number. It's an introductory course. You don't need any prior knowledge or credits or education to go through this. Sean Page is our contact for certificates and credit questions. So the 4 areas we're going to go over today, we're going to understand what an aluminum zinc metallic coated steel is and how it's made. And then we're going to talk about some, at a high level, common type of roofs that we see being made with this product and getting installed. Talk about design elements that need to be considered, and then we'll talk about maintenance and other concerns in the field once it's installed, and how to get the best life out of this product. So aluminum zinc metallic coated steel is usually referred to as Galvalume or Zincaloom. Those are trademark names in the industry. There are also licensing around this that we'll talk about. So this is steel that's been coated with a specially designed aluminum and zinc mixture to give it superior corrosion resistance. Comes in a lot of forms. You can use it bare, you can use it painted. It's easily formed and shaped for walls and roof use, also interior applications, appliances. We're going to focus, of course, on roofs and walls today. And we'll talk about its advantages and best practices when working with it. So what's the purpose of the metallic coating? Corrosion resistance. So we all know that steel doesn't do very well on its own, right? It rusts very quickly. We've got to put something on it to protect it if we're going to use it outside. So most people are familiar with hot dip galvanized. Galvanized is a solid layer of zinc whereas the product today we're talking about is aluminum and zinc combined. We know that corrosion is an electrochemical process, causes the steel to rust, become thin and weak, and lose its structural properties. These metallic coatings are applied in a continuous process prior to painting, if it's going to be factory painted. They are active coatings, and the aluminum and zinc product provides 2 layers of protection. You get a barrier type protection from the aluminum component. You get a galvanic sacrificial protection from the zinc. Now, while this does greatly reduce the rate of corrosion on steel, it does not stop it completely. And we will see real world examples of what this product looks like long term. I have a little cross section here of what a factory painted steel product would look like. The steel in the middle is by far the majority of that total thickness. You would then have your layer of metallic coating, which would be the yellow on here. And then if it's painted, you'd have a little bit of pre-treatment, and then primer, and then your top coat and your backer paint. So again, the metallic coating is very, very thin in relation to the rest of it, but provides a lot of protection and performance characteristics. So take a step back real quick. The product we're talking about is all coil product or flat rolled steel product. For those who aren't familiar, here's some pictures and a little bit of what the process looks like. So we start with flat rolled steel, uncoated steel. It's either called hot band or hot roll typically. We then reduce that down to its final thickness and width that it needs to be for the final product, after which then we apply this metallic coating to it. And that's a continuous process. If it's going to be painted, it then moves to a continuous paint line to get painted, and then is shipped out in coil or roll form to the fabricators who are going to make wall or roof panels out of it. This is a very generic schematic of a metallic coating line. We can put 2 coils on an entry on the left. These payoff reels, the ends are welded together, which allows us to run continuously. So there's always strip in the line. So what these accumulators allow us to do, which is slow and stop sections while the rest of the line continues to move. Goes through a cleaning section, which is really important for aluminum zinc products versus galvanized products. Needs to be a much cleaner surface for good adhesion. Then goes through an annealing furnace, which is actually determining the mechanical properties of the steel. Doesn't really have anything to do with the coating that's going on it, but that's where you get your grade of steel. Grade 80, grade 50 probably being the 2 most common in the construction world. The strip then moves down into this molten metal pot. This is where the metallic coating we're talking about gets applied. So this is at 1100 degrees Fahrenheit. It is the appropriate mixture of aluminum and zinc in liquid form. Strip moves through here. Coating gets applied to the strip. We have air knives, which blow on the strip that control how much of that coating is on the final product. Goes through a lot of cooling to let that crystallization process start and get good adhesion to the steel. And then at the end of the line, we have some finishing work that goes on. And it's going to be painted. We'll put it through a skin pass mill. Gets a really nice, extra smooth surface. Like it's giant rollers. It's like rolling dough through giant steel rollers to make it really, really flat and smooth. It goes through a tension leveler, correct any shape, so we get a flat product. And then if necessary, we can apply some chemical treatments and or clear resins if it's going to be used in its bare state. And then it's recoiled at exit, and it goes on to the next process. This is a little bit of a close-up of what we call the process area where the real work is getting done in the line. This is an example of a direct fired furnace. So you actually are impinging the strip with flame inside the furnace. Helps anneal it, helps clean it, also helps to anneal it to the properties it needs to have mechanically. These radiant tubes are doing that work as well. It's heating the strip and cooling the strip before it enters the pot. And this is what the inside of the pot looks like. There's a giant roll that the strip rolls down underneath and then comes back up, back through the air knives to control coating weight or thickness of metallic coating that's been applied. Here's some pictures of a line. So on the left here, this would be the entry. Those are the size of the coils. These coils are typically anywhere from 40 to 55,000 pounds, so they're quite large when the process starts. So an accumulator tower looks like. In our business, they're all vertical. They're all about 8 to 9 stories high, so large. The third picture here is the pot. So the bottom here is the molten metal that we're talking about. It's a little hard to see, and the strip is coming up and out of it. These two bars sitting across here, the one that says Kohler, those are the air knives that are controlling that coating weight. So the really shiny mirror surface you see here is what that coating looks like before it cools and crystallizes on the steel. And then we do a lot of final QCing and inspection at the end of the line. We test for mechanical properties, we test for coating weight, we're looking for any visual defects as well. So what is this aluminum zinc product? What we're going to talk about today, like I said, the trade name for it is Galvalume or Zincalume. It is specified to be 55% aluminum, 43.5% zinc. There's 1.5% of silicon in there. This is by weight, not volume, so it's weight. So knowing that, you know, the density of aluminum is much, much different than zinc, you know, it's a lot of aluminum by volume that's on this when it's finished, which is key to its performance. It's that aluminum component that's really giving it the superior corrosion protection. The silicone is in there mostly in the pot for wetting out and adhesion purposes. It doesn't really bring anything to the table once the product is finished. So zinc is the sacrificial part, right? We know this, anyone that's familiar with galvanized knows how this works. That galvanic reaction takes place. The zinc sacrifices itself to protect the steel. But as it does that, it wears off, right? You lose that zinc over time. The aluminum, however, forms a protective oxide, also called passivation, more of a barrier, right? It's fairly inert, so it stays around a lot longer than the zinc does. So the rich zinc areas on this product are going to corrode preferentially, leaving the aluminum-rich areas to retain the bond both with paint, if it's painted, but also with the steel substrate underneath. So you get much less edge corrosion long-term with this product than you do with straight zinc. It is made through the same process as hot dip galvanized. The lines, production lines actually look very, very similar. And a lot of companies actually make both products on the same line. They just can switch their pot out between being straight zinc and being the zinc aluminum mixture. This is a cross section at the molecular level of what's going on with this product. On the left is hot dip galvanized, so it's straight zinc. You get these little alloy interface here, these little crystals that grow in it and bond the zinc to the steel surface. On the right is the aluminum zinc product. And I always think it looks a bit like a brain to me, right? So you get the gray matter and then you have these white parts. The white parts in this picture are the zinc rich areas. The gray is the aluminum. So you can see by volume that there's much more aluminum going on here than there is zinc. So what happens is these little zinc areas will sacrifice themselves and corrode once on exposure, but this aluminum stays in place. So while you get some voids once this zinc has been sacrificed, you still have all this aluminum left on the surface doing its job. The product has a really long, interesting history. It was developed by Bethlehem Steel originally. It was first sold commercially under the Galvalume name in June of 1972, so a long time now, coming up on 50 years. But it had been in development for a very long time and many, many years prior to this. A lot of trials and failures, going back to the drawing board. I have had the privilege in my career of meeting some of the original researchers who worked on this product and hearing their stories. And it came very close to not being a product. There's a story, I don't know how true it is, maybe it's legend now, but a story about a couple of the researchers cornering the president of Bethlehem Steel in a limo on the way to an event and pleading their case to keep the project alive and begging him to not kill it. And he agreed, and it revolutionized the coated steel industry. It was a giant step forward and remains the superior product in use today for buildings. Now, it is licensed. They made the decision way back when that they were going to license this technology to other steel fabricators and steel producers. And so you do have to be licensed to use the Galvalume name or the Zincalume name. If you're not licensed, you can't, and you're not privy to all the technical information and support that comes with that license as well. There's about six, 7 producers in the United States right now who are licensed. You can go to the galvalume.com website. It'll show you what companies are licensed in what countries if you ever want to check. We see unlicensed product mostly out of Asia. None in the US that I'm aware of. So we can't use this name unless we've got that license and our processes, quality control, and product is verified and signed off by the BIEC who controls this product. So it's in 28 countries now. And, you know, we've got roofs out there, you know, they sold it first in 1972, but obviously they put out buildings and roofs with this prior to test it. So we've got roofs that are over 50 years old now. And some of them are still being monitored to this day. They get checked annually every couple of years to see how they're doing. And what we're finding is that the service life of this product is probably in the 50 to 60 year range, which is about 9 times greater than galvanized is. And what we're learning as these roofs, the Galvalume product gets older, is that it's actually outlasting the other components on the building, right? It's outlasting the galvanized fasteners and attachments that were made. It's outlasting the sealants that were used, HVAC components, things like that. So great longevity. And about 30 billion square feet of material in use in buildings today. This was probably done 2 years ago, so it's even greater than that now. So again, why this product? It's its long performance and its corrosion performance. It is warranted by most suppliers for corrosion, usually in the 20 to 25.5 year range, depending on the producer. It's efficient in purchasing too, because that aluminum density is so much less than straight zinc. You get more linear footage by weight out of this product than you do with galvanized. Form's great, can be used in all kinds of different shapes, sizes, and profiles, and has a really great aesthetic, especially bare. This is a bare roof here in this picture that hasn't been painted. Galvalume tends to have a very small, uniform spangle surface with a nice silver finish to it, but it's also a great surface to paint. So here's some comparisons, right? Why is it so good? So this is years to 5% red rust in different environments. So 30 plus rural, industrial, and even moderate marine. Even in severe marine, this product does very, very well. 15 to 20 years without any significant corrosion when installed and handled properly. And I have some not great graphics. I have some crude graphics here to show you why that is. So on the left, we have galvanized, right? So it's painted, you have your layer of zinc and then your steel. You get a cut or a scratch to that painted surface. Now you're down to exposed zinc layer. That zinc is going to sacrifice itself to protect the steel, but eventually that's going to run out and you're going to get down to base steel, at which point you're going to start to get unsightly red rust bleed through, which no one wants to see. However, on the right, we have the aluminum zinc product, right, which is that matrix of aluminum and zinc together. So yeah, the zinc, the yellow in this picture goes away, but you're left with all this purple, the aluminum's still there, which is still protecting the steel. So you're not down to steel yet. And it still is allowing that paint all around the edges there to adhere to something. It can't flap free, right? You don't get that paint peeling effect that you might get on galvanized. Same with a drip edge, a cut edge, same phenomenon, right? So over time, corrosion of that zinc on a galvanized product wears away. Now you have an overhang of paint there that's not attached to anything. That's going to come off, exposing more zinc, and you're caught in this sort of vicious cycle that just propagates over time. Whereas with the aluminum zinc product, again, you're left with this aluminum lattice work there, which is keeping both the steel protected, but also allowing the paint to adhere to something longer than it would on another substrate. And here's some pictures. I love pictures. They tell more than the graphs and the words do, right? So, this is real world. These aluminum zinc product and a galvanized product painted with the same paint, put out in the same exposure area over the same amount of time. And this is just a few years, and you can see that there's a difference. And like I mentioned before, is there corrosion going on with the aluminum zinc product? Yes, there is, but it's severely retarded and mitigated versus the galvanized. And what we see in the real world too is that Galvanized in the first, sometimes, I don't know, I'd say 5 to 7 years, might perform the same as the aluminum zinc, but then an inversion takes place. The galvanized continues to corrode and the aluminum zinc product stops and slows down. So we get this reverse effect after a few years. And I mention that because we run into this in accelerated test as well. Accelerated corrosion testing doesn't always show the benefits of the aluminum zinc product. We really need to look at real world. You know, for 1,000 hours in a lab setting for corrosion, the galvanized will look better. But if you let that test run for 3, 4, 5 months, you would see that the aluminum zinc product slows down and stops corroding while the galvanized continues. So we're always a little hesitant if we get a request from architects or builders or specifiers to show the accelerated lab studies of these two products, because they don't really tell the tale. So again, by the numbers, right? So there is an Astm specification for this product, A792, that dictates how it has to be made and the properties it has to meet. There are different coating weights. We talked about the air knives and controlling that. AZ55 and AZ50 are the most common in the construction exterior world. They are going to give you the best performance. AZ35 has some cautions around it. It's not warranted, and you cannot call it galvalume when the coating gets down that low. But we do see its use in non-warranted rainwater goods, and we do see it getting used in interior applications where it's fine for appliances and electronics and that sort of thing, where it's not going to have outdoor exposure. So the number designates a weight. So AZ55 is 0.55 ounces per square foot. Very, very thin. We're talking about a mil, 0.001, 6 actually, or 8 for AZ55 inches. So very, very thin. AZ50 would be 0.5 ounces per square foot. And AZ50 is the most common coating weight we see now in the industry, especially for painted product. So this picture talks a little bit about why that lower coating weight, the AZ35, can be an issue. And again, this is a cross section at the molecular level. What happens when you get down this thin with this coating is the zinc columns can actually reach all the way down to the base steel, which is going to be problematic once they corrode away. Now you have a direct tunnel or line into the base steel, which is going to cause red rust. Whereas on the thicker coatings, very few of those zinc areas make it down to the base steel. You have a lot more aluminum around here to protect that base steel, which is why it's recommended. Other attributes of this product. Solar reflective index, very high. It has really high solar reflectance when unpainted, which is great for cool roof specifications. Most producers of this product do have it listed with the Cool Roof Rating Council, the CRC and/or Energy Stars roofing program, which I know is about to be sunsetted, but it is still out there for reference. Readily paintable, beautiful painted surface, which is where we see most of this go towards. Again, you can use the cool colors, cool paints. That's a requirement. Can withstand a wide temperature range, 600 Fahrenheit continuously without any kind of discoloration, up to 1250 without any severe oxidation over time. In its bare form, it is readily paintable in the field if someone wants to paint it after installation. It can also be powder coated, that's desired. It can be welded in its bare form as well. We don't recommend that for the paint because it burns the paint, but it can be welded. And then here's how it applies to lead. I'm sure you're all very familiar, more familiar with that than I am probably. So, right, you can use it to meet the steep slope roof SRI requirements above initial above 39. The initial on bare galvalume tends to be right around 63 to 67%, depending on producer, so quite high. For the material ingredients reported portion of 4.1, it's easy to report out these ingredients in this product. There's nothing there that's of concern. Painted product gets a little tricky because the paint vendors typically won't release their proprietary formula information. For living building challenge, There are some suppliers of this product that have the red list free label on it in its bare form because it does meet those requirements as well. Now, I've talked about how great this product is, and it is, but there's a few situations where maybe it's not the best choice. Where it's great for residential and coastal applications, right? Even next to the ocean, if it's painted correctly and installed correctly, it does really, really well. Does well in extreme weather environments in general, freezing, hot, doesn't matter. Industrial and commercial settings, it's fine. You can do curved, tapered roofs, and again, very formable. It's great for retrofit. Where is it not suitable? High alkaline environments, specifically wet cement, cannot be in direct contact with this product. It causes the aluminum to oxidize and corrode very quickly, leads to all kinds of trouble. Animal confinement. It does not hold up well in animal confinement. We highly recommend hot dip galvanized for animal confinement applications. Slopes below 1/4 and 12. This applies to all coated steel products, not just aluminum zinc. Direct contact with dissimilar metals and corrosive environments. We're going to talk about that in more detail. Again, that applies to all coated steel, not just this product. And then soil, buried in soil applications like culverts or building edges, or like the posts for guardrails on highways. The Galvalume product does not do well in soil, so we do recommend hot dip galvanized for that. End of the first section, so we will take some questions if there are any.
Thanks, Michelle. I think everybody is feeling a little bit like chemistry class and a bit intimidated to ask questions.
There are no chemistry quizzes, I promise.
I did want to point out for the audience that the Metal Construction Association did a research study about 5 or 6 years ago looking at the expected service life of aluminum metallic coated roofs. And I encourage people to go to the MCA website. You can download it and read more about that. I had one question just out of my curiosity. The zinc sacrifices itself, but it is such a small amount in volume compared to the aluminum. How does the air get to the zinc to oxidize it if it's surrounded by the aluminum?
Well, that's the other benefit, right? Is it's not all exposed. But typically it would be through a cut edge or a scratch on the surface, right, that opens up that coating is where we would see it primarily. I mean, on its own, it's quite well sealed, and you wouldn't, they're going to see very little corrosion on the flat surface. We're talking about cut edge normally. Okay, you can always ask questions later, right? If you think of them later, you can contact Paul or you can contact me, and we'll get you
I encourage everybody. You have a rare opportunity here to with a great resource. So submit the questions. Thank you very much, Michelle. Go ahead.
So now we'll move on to sort of a high-level overview of the types of metal roofs or wall panels that we see this product going into. And there's really two common types, exposed fastened or through fastened roofs, and then the concealed fastener type roofs, which would be typically your standing seam profiles. These are widely available. Most panel manufacturers do both types, concealed and exposed. There's some trade-offs and benefits to each one. Your concealed fastened panels are going to be your standing seam, snap lock, snap seam, mechanically seamed, or batten style roofs. Those are terms you might hear out there in the industry. Your exposed fastened is going to be corrugated. That's the old traditional sort of tin roof look, or trapezoidal styles. I call them box rib in my world. And then metal tiles and shingles can be either. They're typically an exposed fastened, but then with an overlay over it. We'll show examples of that. So standing seam concealed fastener, right? So you're gonna, you have a nail flange or a clip that you affix the panel to the roof, and then you snap or overlay another panel over that, right? So it gets concealed. Sometimes you'll use sealant in there as well for weather tightness, water tightness. The nail flange is affixed using screws usually, and then, like I said, covered by the next lapped panel. Usually want to use a clip that allows for thermal expansion and movement. And in case anyone's wondering, the aluminum zinc product, expansion contraction is the same as any other steel product. I mean, it's really the steel dictating that. It doesn't have much to do with the metallic coating. These kind of profiles we see a lot in residential applications and like light agricultural, light commercial, because they're very easy to install and have good performance. So they go in very quickly, last a long time. We do recommend styrations. That helps remove that oil canning look that you get with light gauge steel. And then the clip versions are going to allow you to do longer spans and greater performance long term than a screwer now. So mechanically seamed are where you have the overlap of the two panels, and then you run a mechanical seamer up it to fold it and seam it together. This is very common in high-end commercial. Do see it on high-end housing as well. Has very high wind uplift ratings. So anywhere where that's a concern, this is the kind of product you want to go to. It also can be used in lower slope applications because of its weather tightness and structural integrity. And like it says here, some of these are structural panels as well. So they can be applied over open framing, which is necessary in some cases. You always use a floating clip on these as well to allow for that movement that you're going to get on the panels. Some of the others that we see are the batten style. So this is where you put a batten piece over those panel interfaces or connections to hide it and seal it. It's a good look. You got a lot of flexibility here with pan width, batten width. You can get different looks, aesthetic looks with it. You can do curved and tapered and conical shapes doing this as well. It is a bit labor intensive. You may need some special gaskets and sealants to get full weather tightness, and probably certainly need someone who's quite familiar with installing this kind of roof. And then the other one is a T panel, which is again, you know, just where the batten is applied over that T connection, like on the right-hand side there at the bottom. Get a little bit higher panel performance out of that. Exposed fastened traditional panels. Again, light commercial, residential, don't typically see this on higher end architectural or commercial projects. So an R panel or a U panel, some examples there. We've got a high ridge and then some styrations and forming in the pan. Very economical, shaped for maximum strength, but optimizing speed of installation, ease of installation. And then there are some crimp type panels that, you know, from a distance sort of give you that standing seam look, but aren't actually a standing seam. There is an exposed fastener on these, but it gives you that nice clean look, but doesn't have the structural performance and probably the wind uplift performance of a mechanically seamed product. Corrugated, again, very traditional is what a lot of people think of when they think of metal roofs, is this old sort of tin corrugated look, which actually has had a bit of a resurgence of late. We see this getting used a lot in wall applications. Sort of industrial look has become really popular. We see it getting used with other, you know, with wood and tile and other things to give a unique look. So a lot you can do with that. The trapezoidal box rib, as I call it, right, has sort of this boxy squared look to it. Again, you can use these vertical or horizontal to give different looks, or you can mix them to get some really interesting design elements as well. Seeing a real comeback in this profile as well in the new mixed use urban industrial settings. And you can get rib heights of up to like 2 inches. So they really good product for large surfaces and large walls. And then tiles or shingles, right? People will be surprised how much you can make metal look like other products if it's painted correctly and formed correctly. So tile sheets, right? This would be an exposed panel with a step to get that. And these are usually stamped, not roll formed products. Structural performance is okay, not as strong as the others we've talked about. Can be challenging to create flashing and trims for these. And then stamped metal shakes and shingles, I really like these personally. I think it's a great look, especially if you use like a printed paint pattern on it. You can get it to look like real shingle or shake. Also see it coated with actual stone granules. The stone coated market, these are really have great hail resistance performance. So we see this used in areas where hail is an issue. High cost of installation, very expensive product, high-end product to buy, but lasts a very long time. So quick overview here, right? So the exposed direct fasten panel is going to be more economical. It's going to be easier to manufacture, ship, and install, faster, wide variety of patterns and looks, right? So if they're pinned, you might not have allowance for thermal movement. So you might get an elongated hole over time. You need to take that in consideration. Not really suitable for low slope or long panel lengths. May require additional sealant or mastic to get good weather tightness on it. But they can be curved and can go over open framing, depending on the profile. Your concealed standing seam roofs, again, it's a cleaner look, larger flat areas, no visible attachments, superior weather tightness, either through the design itself or with applied mastic. Great for thermal movement because you can use the clips to let it float. Can be formed on site or in extra long lengths for continuous span applications. I have been on jobs, actually the one that comes to mind is the LAX the international terminal when they redid it a few years ago. That was, they were actually roll forming on site 50 to 100 foot spans of panels at one time from the ground onto the roof with an on-site roll former. Pretty impressive to watch with planes parked around you. Standing seam can also be tapered or curved and is the best option if you've got a low slope situation going on. But some things to consider. The rib height, right, affects the look and how it casts shadows and how it's going to interact with other elements of the building. So you want to make sure you know what that's going to look like ahead of time. Panel width. Again, aesthetics is important, the space between those ribs, but also the performance attributes, the attachments, and how is it going to impact installation, speed of installation. Environmental factors, again, loading needs to be, weather factors. Does it have a wind uplift concern or a hail impact concern? Making sure you get the right panel for that and that you have the right clip and the right clip spacing to meet those requirements. Other accessories, right? Are there going to be solar panels? Solar panels work great on metal roofs, right? You get a nice flat area to attach to. It's a nice clean look, but you need to know that going in before the building is done. HVAC, walkways that might be on there. Do you need to put snow guards or ice guards, depending on where you're building on the roof as well? Avoiding oil canning, right? This is that buckling or pillowing you get with light gauge steel products. Striations really help that, minimize that. A thicker steel substrate will help minimize that. And although we're not talking about paint necessarily today, your paint system can minimize that look. The less gloss you have on a paint, the less you're going to see that oil canning once it's installed. And then, of course, we have another presentation on paint. If you haven't sat through it, you can join that one in the future. And then make sure you understand what kind of compliance is needed, right? Is there third-party certifications like UL or any local building codes and requirements that have to be met? The end of that section. Any questions on that?
Hi, yeah, Michelle, we've got a couple of questions here. One person is curious, in the Puget Sound area, any rain runoff from bare galvanized has to be treated before it goes into the water. Is that a concern with the aluminum zinc surfaces at all?
It is less of a concern, right? Because there's much less zinc. And to be honest, it's something we've been battling with the state of Washington and some of the counties up there for some time. We have participated in some studies that the state of Washington has done where we expose both bare galvanized and the bare zinc aluminum product. And yeah, the aluminum zinc product sheds less zinc. Unfortunately, Washington hasn't really come up with any kind of set legislation or quantification as to what's acceptable. But if it's sealed with a resin, so when we talk about bare galvalume, it's not truly bare. It usually has a thin, clear coating over the top of it, which also helps with that runoff situation. But when in doubt, it's painted product is going to be the way to go to avoid those concerns. And I know we're also seeing not only the zinc runoff in Washington is an issue, we're now seeing the Salmon Safe program, which is a voluntary program that again is concerned about metals running off of buildings. But painted product is fine. So when in doubt, order it painted.
Thanks. One more question before we move on. If this product is scratched or dented or exposed, is there a treatment to prevent further corrosion?
Yeah, and we'll talk about it a little bit towards the end about maintenance. Painted product, yeah, there you can get paint pens to help touch up scratches that are color matched to the original paint to help seal that scratch. Bare product we tend to say leave alone, right? The way this coating works, you're probably going to be okay unless it's really deep and down to the base steel. You probably don't need to do anything. But if you think it's down to base substrate and it's substantial or there's a lot of scratches, you can go in with a zinc-rich primer and try to touch those spots up. The problem with both of those options for painted or primer is that they're going to weather less well than the galvalume panel itself. So you may see some differential fading or performance over time. Our recommendation is usually that if it's a light scratch and from a few feet back you can't see it, leave it alone. If it's deeper or more prevalent, if there's a lot of scratches on a panel, you're probably better off replacing the panel if you can.
Great. I got a couple more questions here, but I'm gonna let you continue on, and we'll grab them further on.
I will say real quick that there are a lot of technical bulletins on this galvalume or zinc aluminum product available by any of us who produce it and are licensed to produce it. So like you could go to the Steelscape website or the US Steel website or Steel Dynamics website, and there's a lot of bulletins that cover these topics in greater depth and would answer some of your questions that you might have. So if you're really interested, you can always check those out too. Okay. Designing one of these systems for longevity. Does the slope of the roof matter? Yes, it most definitely matters. Right? We don't want standing water. Got to be able to have a water shedding off of it. Otherwise, you're going to have corrosion. As great a product as this is, if it's in standing water, it's going to corrode. So minimum pitch really can affect the life expectancy. Like I said, 1/4 and 12 is the absolute minimum. Like to see maybe 1/2 and 12 is a little bit better. But yeah, it is going to vary according to the depth of the roofing profile. Right, deeper pans will allow for improved water shedding. Concealed fastener profiles are going to drain water better, and then you don't have any exposed holes or anywhere where water can get in. So this is an example here of, right, where water was ponding on this surface. And while it's not red rusting per se yet, you can see that it's certainly oxidizing and that coating is getting eaten away pretty quickly. Again, walkways, catways, solar panels, right? You got to make sure that those are installed in such a way that you're not holding water or debris on the roof, right? That you can still clean it and that can shed off. Any accumulation of dirt, salt, leaves, organic matter is going to cause corrosion issues long term. So, right, facilitate self-cleaning with slope and the way things are attached. And then also doing maintenance and then airflow, right? You really need good airflow under solar panels anyways. That should be part of the design, right? Don't, direct contact with other metals to make sure you're not creating an electrical connection or galvanic corrosion situation. And we're going to go into that a little bit more detail because that's really an issue in marine settings. Where do you locate vents and fume extractors? Fallout from boilers and heaters can damage the surface. You can get this black oxidation or staining. You want to locate it, so that the prevailing winds are helping blow that clear of the roof and then you're not getting fallout. Make sure the height is high enough that you're not getting a lot of fallout right on the roof as well. So spotlight on dissimilar metals, because this is, like I said, this is one of our biggest issues we run into, and it's one of the, what I say gets reported as a failure to us a lot, and then when we inspect it we find out it's a dissimilar metal situation. So this is when you have metals that are apart from one another on the galvanic chart here, and they're in a corrosive environment like near the ocean, right? So then you're going to have one metal sacrifice itself to protect the other. And the environment can be corrosive air, water. It doesn't have to be in water. It can just be in corrosive air. Salt-laden air is enough to do this. So the further away 2 items are on this list, the more the potential is for this to happen. So that becomes important when you're selecting fasteners and other attachments like gutters, trim, clips to the aluminum zinc product. You know, stainless is really a good fastener until you get near the ocean. And then you can see how far apart stainless and aluminum and zinc are down here from one another. Becomes very problematic in a marine environment. The aluminum zinc will sacrifice itself to protect the stainless steel. So you get accelerated corrosion of the panel. So again, trims and flashings and gutters ideally should come out of the same material, right? So it's all compatible. You can use painted aluminum product. That's usually not an issue. Galvanized is not recommended because of the performance long-term. Your galvanized product's not going to last as long. Copper and stainless are sort of a big no-no. There's really the potential to create galvanic issues with the galvalume product itself. And then anywhere where you've got anything exposed to standing water, right? You want to make sure you have proper fall out of your gutters and valleys and what's not. Here's a case example. This is a police station in Hawaii that had premature aluminum zinc corrosion occurring. You can see this red rust that was happening here. This is a copper fascia, painted galvalume panels on top of it. But it was only happening on this lower level. Top level, same design, same products, not having a problem. Well, what we found out after we went and did some studies is that due to the position of the building and the local prevailing winds, and this is on Kauai, so it rains every day, water from this upper copper fascia was blowing down onto the galvalume painted panels below and causing corrosion. So poor design with the copper there. Other considerations, right? We talked about expansion and contraction. It's going to be the same as any other coated steel. So no concerns there. You got to have the right clips so that you can get that floating effect rather than pulling and tugging at a fastener. If exposed fastened, attaching directly to wood or steel purlins can relieve some of that on smaller panel lengths. For clip selection, the simple design is a one-piece clip fixed to the substrate with a floating connection. A dual clip design is going to be a two-piece clip fixed to the panel in the base, which has that floating slipping component as well. We got some pictures here. The panels still have to be pinned in one location to address loads, though. Environmental considerations, again, wind uplift, air and water infiltration rates, product loads like snow and ice, adds up very quickly. Ice dam prevention, coastal corrosion, finishes that might need to be in place if it's painted product. And then the trim and flash, again, needs to match that, so you get the performance of both being equal. And again, this is my disclaimer. I am not an expert on panel installation and design, but we have people who are, so if you've got detailed questions on this, there's other presentations we can give you, or we can get you to the right person to answer your questions for you. Questions on that section? A little quick,
Michelle, we got a couple of questions. We got about 10 minutes left. I'm not certain how much time you need to complete the presentation. Do you want to take questions now or hold till the end?
I can take one. Let's do one question. I'll let you pick.
So this was about metal tile shingles and concern about wind problems and how they hold up in high wind situations, metal tile panels.
Most of them, my understanding is that they have very good wind uplift ratings, most of them. But any good manufacturer should have that information readily available on their product.
And do all the manufacturers have fastener selection information as well?
Yes, they should. If they don't, be leery would be my advice. But yes, the good ones are all going to have installation guidelines, fastener selection guidelines, all of that available, usually on their websites.
Great. We took 2 questions there. Thanks very much. Let's move on.
Okay. So we've talked about how great this product is, right? It has great corrosion protection, but you know, when doesn't it, right? When can premature corrosion occur? Wet cement, we talked about that oil. in soil. That's a problem. Dissimilar metals in a corrosive environment. Wet or chemically treated wood is problematic because it traps moisture, and there's also some chemicals in the fire retardants that are used that can be an issue. So again, fasteners and penetrations, very important. Insulation and how the insulation is going to be used is important. Sealants and cuts, integrations with other materials, and roof elements. Field cutting, cutting in the field, and how you clean up your job site is really important. And then maintenance long-term. So you got to use fasteners designed for an aluminum zinc product. And again, there are guidelines on this out there everywhere. There's a whole technical bulletin for galvalume just on fasteners. Carbon steel, 400 and 300 series stainless steel, and aluminum are really good. Unless you're in a marine environment or a corrosive environment, then you do not want to use stainless. So you want to check for compatibility. Galvanized is generally okay, but not avoid direct contact. You want to use rubber washers and spacers on your fasteners, and then always clean around afterwards. I have a picture here. This is a private home. It's about 300 feet off the surf break in Southern California. Picture on the top was taken in 2008. This complaint came into us as the paint is blistering and failing. Well, the reason the paint's coming off is because of the corrosion that's occurring on the substrate underneath. That fastener and then that clip that you see coming down from it, which is holding a stainless steel gutter up along this roof, all stainless steel. So the panel here, the aluminum zinc panel, is sacrificing itself to the stainless. And you can see that it's down. By 2011, when you peeled it all back, you were down to red rust. So we're down to base steel. There is no metallic coating left in those places. This would continue until that panel is completely disintegrated and gone. But you'll note that the stainless fastener and the clips still look fantastic, and the stainless gutters still look fantastic. That's because of galvanic corrosion. So this complaint almost always comes in as a paint failure, and then we find out that's just a secondary issue. There's nothing for the paint to stick to anymore. That's why it's coming up. Fasteners. This is an example of what can happen maybe with an installer who's being a little careless or doesn't know what they're doing, is if you overdrive these fasteners down through the metallic coating and into the base steel, now you have an opening where water and moisture can get in there, and you're going to get red rust. Now, it presents very similar to the picture before, which is galvanic corrosion, right? The paint is bubbling up, but the mechanism is a little bit different. It's because they broke through the coating. So avoid incompatible materials. Again, lots of technical bulletins on this, so what you can and can't use. Any incompatible materials should be painted, right, to prevent that direct contact. You get a nice inert barrier between there, helps mitigate that. Seal it where you can. Use a neutral cure sealant. Again, there's a tech bulletin just on sealants available. We want to install AC units on similar aluminum zinc curbs to avoid water dams or aluminum if it's welded. Make sure drain condensation doesn't have dissolved copper in it. Here's an example where some copper from these pipes was leaking and draining onto a galvalume roof, causing pretty severe corrosion and oxidation. Edges and terminations. Right, most of these roof and wall panels are going to be manufactured to the length that's needed for installation, but sometimes you need to do some cutting out in the field and at the site as well. So you want to make sure you do that correctly. Again, there's a technical bulletin on how to cut appropriately. Transport and length limitations may necessitate in-lapping, right? So where you're lapping one end of the panel over another. Of course, you want to make sure that's going downhill so water can't run in there and penetrate. Things can't get underneath that lap. And you want to seal it correctly for long-term performance. Double bead and triple bead tape sealants are commonly used. We see it a lot. They work well when done properly. And then always waterproof other joints and transitions, especially pitch transitions as well. Insulation. Fiberglass roll insulation is most commonly used. It's fine. You just want to make sure that it can't get wet, right? So if you have wet insulation on the back side of one of these panels, which is the picture here, this is a wall where water was able to penetrate and the insulation was wet. And now you get corrosion from the outside or from the inside out, from the back side of the panel, because it's staying wet all the time and just corroding that coating. Spray on insulation can be used, but got to make sure they don't have any weird fire retardant chemicals that contain copper, because that'll cause corrosion. And then definitely want to repair vapor barriers, seams, and holes as soon as they're detected. Concrete and mortar. Again, aluminum. The aluminum component in this product suffers from rapid corrosion when in contact with wet concrete. So you want to make sure there's always a barrier there to protect that from having direct contact. It can also be attacked from mortar splashes and droppings during masonry work. If you clean it off right away, it's fine. But if you let it sit up and dry, you're going to have some problems. And it's really hard to clean off after the fact. And then again, don't submerge aluminum zinc products in soil. This is an example here of what you get. So this is a galvalume painted panel that was set right on wet concrete. I think it was a little outbuilding on someone's property. And you can see that it's just eating through the bottom of that panel very, very quickly. I think this was within a year of installation. Wood, green or unseasoned timber shouldn't be in contact because of the moisture. Sometimes there's acidic substances in timber as well that can be corrosive. So you want to use kiln dried or appropriately dried timber. Yeah, so anything that's going to hold moisture is going to be problematic. And again, if it's treated with fire retardant, a lot of fire retardants are copper containing, and that copper is going to leach out and you're going to get galvanic corrosion with the galvalume panel. Storage on site is important. This is really for the installers, right, is to avoid bending or kinking the panels. You also want to store it so that water can't pool on it or sit on it in the bundles or the stacks. We call that wet stack corrosion or storage corrosion. It can happen very, very quickly, believe it or not, in a matter of days if it's very wet. But you know, you got to get it out and expose the air as quickly as possible. Field cutting. So again, you may have to cut in the field. It's okay. There's just some precautions, right? You want to protect those cut edges as much as possible with trim or flashing. The burr, right? The direction you cut is important. You want to cut from the top down. Make sure that burr is placed down so it doesn't hold water on the edge, which will lessen corrosion. Drip or drain ends ideally should be bent down slightly as well to prevent water holding onto that edge by capillary action. And this is really important when we talk about marine settings or industrial environments where there's some corrosive atmosphere going on. Those field cuts really need to be covered and or painted in the field. And there is some edge paint clears you can buy to help seal that edge. Site cleanup. Again, brickwork, masonry work, make sure you get that mortar, any brick, stone work off of the surface as much as possible quickly, as soon as it's done. Swarf, this is metal filings from drill holes or cutting that's done in the field that's left on the surface. Those little filings then rust and leave a stain or actually can embed in the surface of the panels. So you want to make sure you get those cleaned off right away. Once that stain is there, it's really hard to remove. Make sure there's no cables or electrical conduit remaining on the surface that can catch dirt or debris or hold it there. And again, we talked a little bit, there is touch-up paint available, touch-up pins that are available for painted product. Want to minimize it as much as possible because it is going to weather slightly different than the factory applied coating. Maintenance, really important, right? We don't buy a car and not ever wash it or check it or clean it. Same with our metal roofs. The warranties will have guidelines. They should have guidelines for cleaning and what that maintenance requirement is. You know, a little bit of Tide detergent works just great on this product. It's very safe to use a little soapy water to clean things off. Make sure you don't have anything that's trapping moisture. These are from the ZAC Association, right, where had stuff laying on the surface that was trapping water underneath. You can see the panel is just disintegrated with rust over time. Okay, I think we're right on target for time. Little summary here. Any questions? Or you all need to disperse?
Thanks, Michelle. Yeah, we do have a couple of questions. You talked a lot about marine environments and fasteners. Is there a preferred fastener in a marine environment?
I'm sorry, can you repeat that? I didn't catch it all.
Yeah, and you talked a lot about in marine environments and fasteners problems with corrosion. Is there a preferred fastener to use in a marine environment?
Yeah, so first is for marine environments, use a concealed fastened panel so that you don't have any exposed fasteners, or at least you're minimizing it. And then if you, for when you like, you know, the ridges and the hips and stuff, you may have to use some rivets. We recommend aluminum for those applications near the ocean. So yeah, once you get like a mile or so back from the ocean, you can go back to stainless without an issue. But if you're right next to the water, aluminum is good. There are some aluminum zinc alloys out there, coated fasteners as well, that hold up well, that have a compatible coating on them, so you don't get that galvanic corrosion. But again, a reputable manufacturer should be able to talk to you about that. Unfortunately, I see stainless spec'd a lot, and I think it's just lack of education. And they're right, 99% of the time, a stainless fastener attachment is going to be absolutely fine and is probably the best choice, but not next to the ocean. We actually have, I think on the Steelscape YouTube site, there's an actual little video I did specifically around marine environments that goes into that in more depth if anyone's interested. In that, we do have presentations specifically around marine work.
I think we have time for one more question. I think this is a really good one. When you're performing a roof inspection, what should the inspector be looking for?
Once it's installed or prior?
After it's installed, just kind of a quality assurance inspection, or even maybe a warranty inspection, that kind of thing. What kind
of? So you want to look for, look right that the site has been cleaned up well, that the fasteners appear to be in good condition, right, and are consistent throughout, that there's not a lot of scratches or dents on the panels. You know, I've seen some job sites right after they were installed, and the surface of the panels is scratched really bad all over, right? And that's carelessness, then dragging a panel over another, that kind of thing. So really, I mean, if it's good, nothing's probably going to jump out at you, but the bad stuff usually does, right? If there's debris left on the surface, if the fasteners appear to be done inconsistently, like, again, dents and scratches are going to be problematic.
What about say 1, 2, 5 years later, you're up on the roof making sure everything's okay? Are there any kind of danger signs? Hey, look, I got a problem here I should be addressing. Certainly. Well, you should be doing maintenance every year. That's in most of the warranties. But yeah, you want to look for accumulation of debris, right? Or if there's water standing or pooling somewhere. If you're seeing any kind of discoloration in one area versus the rest of the roof, there's probably something going on that needs a little bit more investigation. If there's a lot of dirt collection somewhere, certain environments, especially down around the Gulf, organic growth can be problematic. It can in the state of Washington too. You want to look and make sure you don't have lichen or anything else growing on the surface. And that really stands out, right, is that black or dark green colored speckles on the surface of painted product. But yeah, look for any signs of red rust or red rust staining somewhere. It means you might have a problem going on as well. Well, Michelle, thank you so much. What a great presentation. We didn't quite get to all the questions, so I'll remind everybody you're going to get an email tomorrow with a link to get technical answers to questions you might have and ways to follow up with people, as well as be able to download this presentation or even watch it again. So that will all be in the email tomorrow. Again, a reminder about the AIA credits and certificates. All that stuff is going to be handled automatically. And just please give us 7 business days to take care of it. And I think that's what we have. After you hang up here, there's going to be a survey. We'd appreciate it if you take the survey, but especially Michelle, thank you so much for a great presentation. Really a good one, and I really enjoyed it. If you want to hear about future webinars, you can go to www.metalarchitecture.com. Thank you all for coming. Stay cool, stay safe, and have a great summer. Bye.
Thank you, everyone. Thank you, Paul.